Hey, what's up guys, it's Jack here with RithinkTech, and in this video, I'm going to show you guys how a 3D printer works, what the parts are, how to 3D print from start to finish, and basically just an introduction to 3D printing video for beginners or people who want to learn. So let's get right into it. So what can be 3D printed? Basically anything you want, basically any solid object you can print out. Like see here on the screen, you can see sunglasses, a screw, a milk jug, a boat propeller, pretty much any solid object you can print out, which is awesome. So you guys might know of some famous 3D printers like MakerBot or Ultimaker, and these printers are expensive, but they're really high quality, and they both are good for beginners, but they're probably too expensive for people to start out with. So I'm going to show you some different options you can use that might be a little bit less known, but still will get the job done. The 3D printing process. So this is the core of all 3D printing. Everybody follows this procedure in order to 3D print. So we always start out with a 3D CAD model, a three-dimensional model on the computer of the object you want to print. And from there we export that model as a .stl file, a stereolithography file. And from there, we can import that STL file into our slicing software. So we'll get to different slicing softwares later in this presentation. And from there, in the slicing software, we can edit the layers, the tool path, and the temperature, and the color, and how fast you want to print. Basically, just edits what the printer is going to do. And from there, we send that code that the slicer makes in a .g-code file off to the 3D printer, click print, the printer makes our object that we made in the CAD model or downloaded online, and creates a three-dimensional object. So how do 3D printers work? So there's two main types of 3D printing. There's FDM, which is the most popular one, field deposition modeling, and SLA, which is stereolithography. So FDM printers are the most popular because it's an additive process. It's not that messy, it's not that hard to use, and it uses filament, which is pretty cheap. So this prints at about 100 to 20 micron layer thickness. That's the lowest that most printers can go, which is really, really thin. So you're gonna get nice and smooth prints with FDM. And like I said, FDM is an additive process. So it uses a spool of filament plastic, and it extrudes that through a hot nozzle at 195 degrees Celsius or around that temperature. And it extrudes it through a cone-shaped metal piece called the hot end, and extrudes that out into a really, really small, thin strand. And the printer moves around in three-dimensional X, Y, and Z planes and squishes those layers onto the bed on top of each other, as you can see here. So that's the most common type of 3D printing. And the next type is SLA printing, which the layers aren't as thin, but you're still going to get amazing print quality because there's less moving parts than FDM printers. So as you can see here, SLA printing uses a projector or a laser to harden resin as the build platform moves up. So in SLA, your print prints upside down actually. So it depends on what you want to print. SLA is also more expensive, FDM is cheaper, so that's why most people go with FDM printers. So different filament types. Most people print in PLA because it's less toxic, it's easier to print, and there's more color options. But there's also ABS, which is what they make Legos out of. It's a harder, tougher plastic, which is also harder to print. There's nylon filament, there's carbon fiber, there's TPU, which is flexible. There's wood, metal, glow-in-the-dark, PVA. All these materials can be printed from a 3D printer. So wood filament, glow-in-the-dark come from PLA too, which is cool. So if your printer can print PLA, most likely it can print wood or glow-in-the-dark. So types of 3D printers. These are the basic types of low-cost consumer-grade 3D printers. There's a RepRap printer on the left here, as you can see. It's an additive process. That big metal part in the middle is the extruder, and the blue tape is the bed. So that printer has a big bed size of about 8 by 8 by 9 inches. That's the average size of a RepRap printer. In the middle here, we have a Delta printer, which is still FDM, but it uses 3 motors and 3 carriages to move the nozzle around and up and down on a circular bed. So that bed is usually a little bit smaller than a RepRap printer. It's about 6 inches in diameter. On the far right, we have an SLA printer. Now, these are more expensive, but the quality is a lot better, but they don't have as many materials as FDM printers. So CAD, computer-aided design software. So there's two ways you can find models. You can either make it in a CAD software or download it online, which I'll get to later. So my favorite CAD softwares and the most popular ones in the 3D printing industry are Google SketchUp and Autodesk Fusion 360. These are really easy softwares. You can export that STL file to send to your slicer software. And they're really easy for beginners, easy to learn. They have lots of tutorials online. And they're all around great CAD software. So I really recommend them. So here we go, how to find models online. This is what a lot of people do for just a quick model. There's Thingiverse, which is the most popular one, and myminifactory.com. Now, most people use these to just find quick models. They can download them directly as an STL file, send them to that slicer software, and print any object you would like. Now, Thingiverse and myminifactory have almost any object you can think of, so I would definitely recommend going there first instead of making your own in your CAD software. Now, slicing software. So there's many different slicing softwares, and I just listed 3 here, which are the most common ones. So Makerware, or it's called MakerBot Desktop now, is the slicer software for MakerBot printers like I showed in the beginning. Cura is for Ultimakers, like I showed at the beginning too. And Simplify 3D is what most people use for rep printers, printers they build, Delta printers, things like that. But Cura and Simplify 3D both export as the .G code, which most 3D printers use. MakerBot and Makerware export as a .MakerBot file, which only MakerBots can use. So file types and slicing types. So as I said, you're going to import your .stl file into your slicer software, and your slicing software is going to export it as a .G code, which goes directly into the printer. But MakerBots use a .MakerBot file type. But they're both basically the same. They're ones and zeros binary that tells the print head exactly where to go. So it says go 20 spaces this way, 4 spaces that way, down 10 spaces, pretty much just like that. Extruders. So there's single and dual extruders on printers. Sometimes there's more than 2, but mostly 1 or 2 print heads or extruders. So extruders like these are only on FDM printers because they're additive process and they extrude the filament out of the nozzle. So single extruders can only print in 1 material type, but dual can print in 2 material types, as you can see on the right. So the dual one has 2 tips, and here, as an example, it can print black and white at the same time. So your model can have 2 colors, which is pretty cool. So bed types, heated beds. So most 3D printers should have heated beds, which helps the material stick to them better and won't pop off in the middle of the print. So there's glass beds and painter's tape beds. Glass beds have a nicer bottom surface, but painter's tape beds are usually able to stick the print down easier, and you can replace the painter's tape if some comes off, while the glass beds, if you scratch the glass, you can't really take it off and replace it. But glass beds, if you scrape the glass, you're going to have to buy a new one, which gets pricey after a while. Infill is how much plastic is inside of your model. So I recommend anywhere from 10 to 35% infill, but you can go up to 100 or down to 0. 0 will have nothing inside of your print, and 100 will have your model is going to be pretty much solid. So perimeter layers, 1 to 2 is how many times your extruder goes around the perimeter of the object. So 1 layer is going to be going around once, 2 is going around twice. And bottom layers are how many layers of solid material print at the bottom of your object. So I recommend about 2 to 4 bottom layers, which works best. Bridging and overhang. So on the left, you can see that the printer is trying to print a 90-degree angle, which is impossible because it can't extrude in midair and stick to air. That's not possible. So horizontal overhangs are like these, but most printers can print about 45 degrees, and over that it'll start to overhang, and your print will look like this. So you should use support to fix this issue. On the right, you can see the Christmas trees have a big 90-degree overhang, but the center one has support, which is that grid-like material that your slicer software adds to your model. So don't worry, after the print is finished, you can just pick that stuff away. It'll come off nice and clean, and your object will look just like you made it in the CAD software or downloaded online. So object orientation in your slicer software is very important. So on the left, you can see bad orientation. The red is the object and the blue is the support. And that's not going to print properly because you're using a lot of support. And you want to use as less support as possible because it helps it print faster and the surface will be a lot nicer. So on the right, you can see it's good orientation because there's a lot less blue, a lot less support in your model, and it'll print faster too. So use the least amount of support and overhangs as possible, and think about strength as you print your object. So as you can see, 3D printing is an awesome technology. That's my video on the introduction to 3D printing, and I want to know what you guys are going to print. What you want to print, what you have printed, what you learned from 3D printing. Comment down below. I'll make sure to write back to you. Please subscribe to my channels for more videos like this. I hope you learned something, and I'll see you guys in the next video.